Hello everyone, how are we in the post-lunch slump? All caffeinated? Yeah? Apologies for the frog in my throat, getting over a bug, or as in a cold, not a software bug. Imagine if you got ill every time you actually wrote bad code. Anyway. So today I'm going to talk about modernizing authorization, going from sort of basic roles and what does that look like when you evolve a system to go to more of a decoupled attribute-based authorization or ABAC approach. Quickly, I'm Alex Olivier. I'm really a software engineer at heart, but ended up in the dark world of product about 6 years ago. Started out at Microsoft working on enterprise consultancy type work, a lot of .NET, a lot of NHS and banks type clients, and then made the switch to startup land about 10 years ago and worked across different MarTech, e-com, supply chain, fitness, a few other different verticals, but always very much focused on the data and infrastructure side of things. And one of those areas I always had to kind of look after was the authentication, authorization, directory, audit, that story. So it's an area that I've spent a lot of time pulling my hair out over, and I, for some reason, turned it into a full-time job. So here I am. But I work on the open source project Cerbos and the company behind it. Not really going to dwell on that, but I'll come back to that at the end. So just to make sure we're all on the same page, I'm going to be talking about authorization with a Z, or Z, rather than authentication with an N. So just to be completely clear, authentication is when someone authenticates, you ask them for a credential, username, password, etc., get back a trusted identity. Whilst authorization is once you know who a user is, what are they allowed to do inside of your system? What are they authorized to do? It's just really annoying those words are so similar, and the fact that they're concatenated all the time to auth N and auth Z. But that's the world we're in. So I'm sure everyone knows the quote, in this world nothing is certain but death and taxes. As a both engineer and product later on, I definitely like to add on to this, ever-changing requirements of authorization. In previous roles, I've had to build an authorization layer into our various SaaS businesses. And in one case, I ended up having to rebuild that system 3 times, and each time took 3 months with my engineering squad, because the requirements changed to such a point that the nice system you thought you designed suddenly doesn't fit the new requirements, and you end up rewriting the thing, and it was a colossal waste of time, and there wasn't really an off-the-shelf solution to it. So through this, I'm going to kind of go through the process of scaling a company. These are all the different stages that I've personally kind of gone through when it comes to authorizing access and identity and access management inside of a system, and kind of the pivot points where you need to kind of rethink how you approach authorization. So start in the early days, so the blissful days of roles. I'm sure everyone's kind of familiar with this. You end up writing bits of code into your application where, let's say, all your internal employees, if you have your email address that ends in your company's domain, yeah, you're an admin, you should be able to do everything. So you end up putting simple if statements in that look something like this. Where you literally go and grab the email address from the JSON Web Token or some session, and you see, has it got our domain in it? Yes, then go and do the action. And that's pretty easy. Maybe you can use like a scope inside of a token as another way of doing it, but ultimately it's a binary. You're either an admin or you're not. And that kind of works for the initial prototype, let's say. So now let's go on, let's say you've actually got a product, you've got a team going out and selling it, and you end up in that wonderful world of pricing and packaging and feature flags and all this sort of stuff. And suddenly you want to maybe rechange how you package a product. So now you have a set of features that for some users need to have access in one way because they're on one package, and then you've got a new kind of model where you want users to be able to access a different set of features or a different set of quotas, let's say, based upon that project, that new kind of feature plan. So now you go kind of back to the code and you take that basic if statement before that's just looking at email address, and you go and chuck an OR in there and say, okay, let's go and look at what package that belongs to this kind of company object, let's say. And if they got the premium package, then yes, okay, fine, they can go and do that feature. And you can maybe go and use like a feature flag system for this as well. Not too bad, especially if your application's pretty small, not too much hassle to kind of put in there. Okay, now let's go to the next step. So I had great fun being the guy responsible at my previous jobs to deal with the whole downfall of the safe harbor agreement between EU and US, and we had to then bifurcate our entire infrastructure. We were storing end user customer data, and now we had to go and figure out, like, okay, well, how do we grant access correctly based on this new legislative environment that we're in, before things like Privacy Shield and such came around. So our sales team were quite keen that we wanted to go and actually start selling to the US or in the EU and keeping them separate. So now we have to go and add another check into our application code. So now we're checking whether the email is the company domain, checking the package, and then we have another check to work out, okay, which region is this user in? If they're in Europe, they should only be able to go and access features on the European kind of data set. If they're in the US otherwise. At this point, okay, the logic's getting a bit more complicated. You can still maybe use scopes of this around like region of data. There's sort of language-specific or framework-specific libraries, Castle, Caspin, these kind of tools, which could also help you sort of centralize that logic a bit more. It's like, great, okay, we can get by with this, so let's kind of move on. Next one, you notice how much sales cause headaches. But anyway, next one is we come on to like, let's go and sell to enterprise organizations. So one of the experiences I had in one of the e-com martech platforms I was working on is we just sold to Staples and Emirates Airlines, two massive organizations, and we were going to onboard them to our platform, and at the time our platform had 3 basic roles, sort of admin, editor, and viewer. And both rightly, these customers turned around and said, I cannot shoehorn 70,000 employees into those 3 roles. That's just not going to work at us at scale. We need to have proper user groups and roles and hierarchies and teams in order to kind of permission that down. So we had to go back to the drawing board and kind of look at our code base again, and kind of the most simplistic version is you add something like groups, let's say. So now that logic is now extended a bit further. Check the email, check the package, is this person in a group, make sure they're accessing the data region. And this, as you can see here, this logic's getting quite large here, and this is the point where you're probably going to be looking at some sort of directory system, LDAP, that kind of thing, to maybe store some of these attributes and memberships, or you end up writing more and more spaghetti code, which sucks. And then after you started selling to a few of these larger businesses, you kind of get fed up at answering those security questionnaires, because you get kind of asked the same sort of security requirements, those sort of things, the same questions around access control, processes, etc. And so someone with a lot more experience than you probably comes along and says, well, let's go and get our SOC 2 or ISO compliance. And I've been through both of these a few times now in a few different companies. And it is worth the effort because it does answer a lot of questions down the line. But one of the things particularly that I used to get tested on, let's say, by auditors quite often is around access logs and audit logs and access controls. So at the time, we were running like a load of different microservices, and I used to get dragged down to a dark, dingy conference room in the basement by an auditor who wanted me to demonstrate various things to them, and one of them was like, what is your access control logs? And the first time I did this, I ended up sitting there grepping through logs in S3, which you could see their eyes glaze over, which is fair enough. Mine were as well. So you end up going back to your different microservices, and let's go and put in some sort of standardized logging. And there's numerous log libraries out there, and you go and start to instrument this kind of logic across the app to put a specific log line when, an allow or deny decision was made by your access logs. And you get kind of a good way with this using a log library and then sort of like some log collection system to kind of centralize it all. But ultimately, you have to touch this authorization logic and now the audit part as well. And then at some point in this journey, could be earlier, could be later, the discussion around monoliths, microservices kind of comes up, and you want to start, say, maybe do some machine learning type work. So you have this little thing that's running in Python, and your main backend is in Node, and you've got this like legacy .NET component, and things get kind of a mess. Well, not a mess, but things get kind of a larger estate to deal with. So what happens now is when your authorization requirements need to evolve again, because you've got a new client, you've got a new feature, you've got a new package, etc. That ultimately business logic now needs to be translated into every language potentially that you're using inside of your system. If the Python service needs to do some authorization checks, you've got to take that business logic and write it in Python. If your main front-end service is in, say, Node, you're going to have to take that and write it in Node. And then every time the requirements change again, you're going to go and touch essentially your entire estate and go and update the logic and translate it, and that's obviously going to be prone to errors. You're going to have to do a lot more testing, et cetera, et cetera. And there isn't really a way, at least I found at the time, to kind of approach this in a maybe a bit more sensible and scalable approach. So what is a sensible and scalable approach? And we're now in the world of very much, build versus buy or everything as a service. And the parallel I always point back to is authentication. So go back 5, 6, 7, 8 years ago, if you wanted to build authentication to your application, you would have that users table in your database. It would have a column of username, another column of password, hopefully a sort of hash, etc. And then you just go and do a check. Authenticated, great, off you go. But then people start wanting to do single sign-on or log in with Google, or log in with Facebook, etc., etc. And it became sort of such a overhead to go and add another authentication provider. However many years later, we now have Auth0, obviously acquired by Okta for however many $1 billion. And it's what we generally find talking to users of Cerberus, at least, is it's just like the go-to. Like, we're not going to waste time and money building an authentication provider. It's a solved problem. We'll go and use one of these services or go and pick one of those open source projects off the shelf to go and do it. And we always found that there was a bit of a gap for the next step after authentication, which is the authorization piece. So what would this authorization as a service sort of type model look like? Well, the inputs really would be you have a user who could be a human, or it could be like a service account or an API key, so like a principal, to use a generic word, trying to access, do some particular action on some particular resource inside of your system. And that would, your authorization service would take that as an input, and that authorization service also needs to take in sort of the actual logic or the policy of who's allowed to do what. And what ultimately comes out of that service would be either an allow or deny decision. So principal user action, can they do this action on this resource? Evaluate the policies and return back a hey, yes or no. And that can be a nice encapsulated block in your architecture, as it were. So if we were to look at an example of like how do we actually map kind of a business requirement to policy, this is an example of a Cerberus policy, but the same kind of model applies to lots of different solutions out there. But essentially, you're taking or decoupling that hard-coded big if-else case switch style statement that we saw evolve there and defining it as a policy definition. If you're familiar with Kubernetes, we use a similar kind of format for this with the Cerberus project. But really, you're defining first, primarily the different resource types inside of your system, and then all the different actions that users could do upon that resource. So here we have read, create, update, delete, your basic CRUD methods there. But really, this is very open-ended for you to define based on your end user kind of business logic of what the actions are. And then it's not just about assigning which roles can do each action, which would give you ABAC, role-based access control, but how do you get to the next level of granularity? How do you actually authorize based on attributes about either the user or the resource they're trying to access? And the best example of this is the owner role. You could never define an owner role statically as like a group or an ABAC role, let's say, because owner of a resource is contextual based on who the user is and the resource they're accessing. So you would need to have a condition that says, if the owner ID attribute of the resource is equal to the ID of the principal making the request, then they are the owner of it, thus they should be granted extra permissions. And that's where you really grow from RBAC to ABAC, role-based to attribute-based. And defining all that as policy has some advantages because now there's a single point, there's a single definition of exactly all the different resources, all the different actions, and under which conditions those actions are allowed in a place that's versionable, auditable, can be tested independently, and sort of scaled out this way rather than having to go and touch all your application code every time something changes. So the other kind of trend that's occurred, we're all in the world now of Kubernetes, obviously. Here we are at Civo Navigate. But this model I personally really like of like decoupling or extracting out of your core application code into either a sidecar or a service of like common components. So if you look at something like the OAuth proxy, which you might be running as like a sidecar to some of your services inside of your cluster, that's a very defined basically API or interface of exactly how that works. Request comes in, it figures out if you're authenticated. If it is, passes the request on. If not, redirect you to some OAuth login flow. But in the world of containers and Kubernetes, etc., you can see the same model of things like logging and metrics, Prometheus instances and those sort of things. This model works really well for these very predefined bits of logic and services and containers that need to work. And particularly when it comes to scaling, this is another kind of really useful one that I've kind of used in previous systems, which is when you need to do something that has to be low latency, but also at scale. Being able to decouple and run as a sidecar some application logic which then would scale up and down with your application auto-scaling has a huge benefit because now you're not potentially relying on this other service that you have to scale up and down along with your application along the hot path as well. In terms of what this could actually be, obviously, Docker container is the most obvious way for this. But we now look at the world of WebAssembly modules and like, what does that look like if you compile your logic down to a WASM module and then have that as an asset that other parts of your system works? You can kind of have the same model where you have this specialized component that you scale along with your application. So what does it look like in practice? I'm going to swap mics and walk you through this diagram. Hey, yay. Okay. So very basic system architecture type thing, but this is ultimately we're going to be looking at the request flow of, say, a simple web API. You have your end users, request comes in to your application, and this application block would represent your monolith, your web and microservices, your parallel lambdas. It kind of doesn't really matter, but ultimately that request comes in, and you know two things about that from that request. Firstly, you know who the user is, because that request would have a JOT associated with it, or a session cookie or something, which you can then go off to your IDP, go and look up the further attributes from your directory system, like the LDAP or AD or something like that. But ultimately, you can go and fetch the user's identity and their roles from your system. The other thing you know based on that request is the actual resource they're trying to access. So it's like a GET request to /expenses/123. So you know that they're trying to go and read a expense resource, let's say, from your system with an ID of 123. So you can go and fetch that from your application database. And then normally, that's where you would then have that massive if-else case switch style statement that we saw, where you're comparing the attributes about the user or the principal and the resource attributes from your database, and then you kind of return some sort of decision. With the model where you decouple that out and start making use of this authorizing service, rather than doing all that logic inside of the request handler in one of your services, or all of your services in worst case, you now package out that information about principal, resource, and action, and then call out to that service either directly with an API or use an SDK. For Cerbos, the API is a gRPC or REST endpoint. We have SDKs for most languages. But really, you send over that request, principal, resource, and action. That authorizing service then has policies loaded into it. Those policies, as we saw, those kind of YAML definitions can be stored outside of your application code base, could be in a Git repo, get a nice sort of GitHub style story there. Could be in a bucket, could be on disk, could be even a database. But ultimately, your authorizing service, say Cerbos, would pull in those policies and really hold them in memory. So that request comes in, principal, resource, action, evaluate your policies, and then a couple of things happen. Firstly, you create an audit log. This request came in for this principal, for this resource, for this action. Generate an audit log that's now going to be in a standardized format because it's being done by a standardized service inside of your stack. At this time, this principal tries to do this action on this resource. It was either allowed or denied by this particular policy. This is great for anyone that's in regulated industries and anyone that's getting compliance in their certs in space. It saves so many headaches when you're being audited. That goes off, great. You can send it off into your log collection system, your SIEM system, those kind of things. What then comes back to your application is a very simple yes/no. Is this action allowed or denied? So now that if statement that before was going to be that big complex hierarchy of logic is now a simple, did the authorization system say allow or deny? If yes, do the action. If not, return some sort of error or 403 or something like that. So your application code is now very simple. All the logic is now encapsulated. This logic can evolve and change over time. You get a nice audit log, so you don't have to instrument every service differently. When the logic changes, this updates. You don't have to touch this anymore. That is just the API is the same to your application, and then your end users get the response back based on their permissions. So what does that really look like in the code? You know, before, and this is a pretty simple type of permissioning model, big complicated logic. After, you just basically look at the API response to see whether that particular action is allowed or not. So at a high level, just to kind of wrap things up, really the advantage of this model is now that logic is defined centrally. In the case of Cerbos, as the open source project, that logic could be in a Git repo. This is really the one we recommend the most. We release tooling to run a full managed CI/CD pipeline. You can write unit tests directly against Cerbos policy, which is something that's kind of tricky to do if that logic is embedded in your actual application code. So you write all your test cases, you give it fixtures for principals and resources, expected response, run that in your pipeline. You can do full branch-based development, etc. You configure your authorization service to pull up policies from that repo, configure it to pull down changes, etc. So ultimately, your authorization policy can evolve independently of your application code. So we see with some of our users, basically the engineers have done the work to implement the Cerberus logic and deploy the services, and they literally hand off the policy management to the person who actually owns the authorization requirements, usually a product owner of some sorts, to manage it to themselves. Developers now have to look at it again. By extracting the logic out or decoupling it into standalone services, it's now mean you're free to make whatever architectural or language decisions that you want. If you want to have some service in Rust, go ahead. You don't have to worry about authorization, or as long as they can make an API call out or an HTTP call out, you can get an authorization decision consistently without having to worry about implementing authorization into that new service. The GitOps, I think, that's a known entity these days, all the benefits I get from that. And then also the other side of it is because your policies are now in something that's version controlled, you also have an auditability story around the actual policies, not just the decisions, which is great, and that consistent audit trail. Now, obviously, it's not all upsides. There are some other challenges here to be aware of, but I personally think, from my own experience, it's worth it. There is another service to deploy and run and scale, but taking advantage of best practices around how you deploy it, auto-scaling, use things like a sidecar, making sure that by using Sidecar, it's inside of the same pod. If you're using Kubernetes, you're not making requests between nodes. We even allow you with Cerberus to make requests through Unix sockets directly. When it comes to actually writing the policies themselves, obviously there's a new DSL to kind of learn for writing that logic. We stuck with YAML just because we've generally found most of our users deploying in Kube, thus they're happy dealing with YAML files, love it or hate it. And obviously there's kind of a new component in the critical path, but through sensible deployment, sensible processes, it's really something that is manageable. And again, the benefits sort of outweigh the downside when it comes to that. So yeah, just to wrap it up, Cerberus is the open source project. We released this a couple of years ago. We're very pleased. We got users like blockchain.com's trading platform runs on this, Utility Warehouse, big energy provider here in the UK, Envoy, a few others are just some of the few companies that are happy to say they use Cerberus. But it is all open source. Go and grab it, Apache 2 license. If you're happy to run, deploy things, you never need to speak to us. It's all written in Go. If you like Go, that's great. Off you go. No pun intended. Also, we have a booth next door, and we've got some T-shirts and stickers and such. So please come and say hi. And yeah, any questions? Yeah, on time as well.
Thank you very much for the talk, which is very, very useful. I would like to ask about, like you mentioned and explained very well, like why is it open source and why it's centralized. But you mentioned also this is very scalable. So can you explain on the scalability, because it's not that obvious?
Yeah, absolutely. So two things with that. Firstly, kind of my background is building high throughput, low latency systems. So in my last business, we were doing orders of 30, 40, 50 billion requests a day through our stack. So that's just by default the kind of scale that I want to make sure everything's designed for. So firstly, Cerberus is stateless. So you're not maintaining any state. There's no requirement to synchronize information about your users or your resources into your authorization layer. That should remain in your master store of who your users are, generally your IDP, and your resources should stay in your application database. You're not having to synchronize. You don't have to worry about things like eventual consistency type issues. All the context about your resource and your principles are sent in that request to Cerberus at request time, so it's always going to be fresh. And because it is stateless, when it comes to scaling, you can just create 10 more, 100 more scale up of the authorization layer as need be. We have users that run Cerberus in Lambda, and it literally just spins up for one request and dies afterwards, as and when need be. And because it's not having to do any fetching of state or reading from state from disk, there's no IIO involved. All the evaluation is done directly in memory. So once it boots up, it pulls the policies down from the policy store, obviously takes the YAML converter to far more optimized, and then executes it directly in memory. It's not having to hit disk. And because you're not storing that state, you're not having to scale up a database or some other data store alongside it. Hence, you can just spin up 10 or 100 Cerberus instances as your application needs. So that's from like a technical scale point. And then more from like a use case or a business kind of side of things. Because the logic is now encapsulated in policy, with Cerberus, we have concepts like derived policies, so you can reuse logic between policies as well. You can actually scalably define almost your base logic and then extend it for different users or scopes or tenants inside a policy as well. So it scales kind of logically as also.
So my question was, why YAML in terms of languages?
Yes.
There's lots of great languages out there that you can write a complex logic and all that kind of stuff. I saw in your example there's a fairly gnarly kind of nested set of conditions in there.
Yeah.
So why YAML, but also how do you approach testing on those kind of combination of different logic and things?
Yeah, so YAML, if you look at the format, it will probably look very similar to a CRD if you're in the Kubernetes world. We wanted to kind of fit into that paradigm. So cloud native, which I know is more a marketing buzzword these days. There's a very rich ecosystem of tooling around it. So YAML for the data structure, you can do it in JSON if you want, obviously. But YAML for the overriding structure, and yes, there are some gnarly ways of doing logic in here. The actual expressions are using Cell, Common Expression Language, which is a Google open source project for doing sort of binary type logic, or Boolean type logic inside of your system. But when it comes to testing, as well as defining your actual policy, you can define fixtures for both your principals, resources, and something called auxiliary data, which is like metadata as well. And then for each policy, you can define tests in the sense of, for this resource, for this principal, here are the actions and the expected response. So this should be a deny, this should be allow, etc. And then as part of the Cerberus tooling, we have a Cerberus CTL, see where we stole that from, which will actually firstly compile your policies to make sure they fit the schema, and then actually run all those tests to make sure you get the expected outcome. We also just more quality of life type things we do as well. We publish the JSON schemas for all the definition formats, so you can light up your IDE with IntelliSense, autocomplete, those sort of things, just to make the developer experience quite well. And then for actually writing this logic to make sure you're on the right track, we have a whole REPL where you can actually test out expressions and conditions before you do it. But ultimately, we always say, make sure you write some tests against your policy and have that as part of your pipeline also.
Hey, let's say you had an enterprise customer that wanted to dynamically manage roles and permissions. Mm-hmm. Instead of statically defining roles in a policy schema, could you have your application database maybe store kind of roles and scopes, and then can you just send these scopes to kind of the authorization service, or what is the best way to implement something like that?
Yeah, so in the request that goes from your application to the authorization layer, you're passing through all the memberships of roles and scopes as data. So Cerberus, in this case, doesn't store that in its own database. You're providing all that up front. So we always say, use your existing IDP or whatever you have in place for managing roles, because you probably want to have a UI in your platform to allow users to give different roles to different groups, etc. Don't change that. You should keep using that. Your IDP is the right place to store role memberships or team assignments and those sort of things. When it comes to Cerberus, this is the decision layer which takes those roles and essentially maps it into which permissions they're allowed. When it comes to enterprise teams, let's say you want to do multi-tenancy where you have different org structures, etc. One of the capabilities we have with Cerberus is create something called scoped policies, which basically allows you to do hierarchies. So you can define the basic resource type definition, but then you might want to create a variant for customer A versus customer B and those sort of things. And that's where you can provide those overrides. And that was built off a real pain I had in my previous role in that kind of capability. There is a way to actually programmatically define all these policies as well. So if you want to be really dynamic and actually update and write new policy on the fly as you maybe create a new tenant inside of your system, there's a whole secondary sort of admin API, we call it, on top of Cerberus as well, where you can push new policy at runtime into the environment. Cool.
In this pattern, is there a way of protecting the policy? If somebody alters the policy in an unauthorized way, then they're going to potentially bypass all of the authorization in the system. So, is there maybe the concept of signing the policies or giving them signatures or something like that?
Yeah, so the way we've seen users implement that is as part of their build pipeline for the application, they also build a specific container which has inside of it Cerberus, but also they bake in their policy. So you have one deployable asset, which is your application with serverless in it and the policies, and those policies are just read from disk, essentially, but inside of the container. And then your existing workflows in terms of signing containers and that kind of just works. You don't have to use a serverless instance pulling the container. Obviously, the downside of that is if you wanted to change policy, it does mean redeploying that container. But kind of the options there for that, and that's sort of how we see more rigorous, let's say, from a security standpoint, businesses implement serverless because they just build a version of serverless that has the policies baked in it. Excellent. Well, come next door and say hi, but otherwise, thank you very much.